Alright guys, last but not least is just to go through and do some practice with you guys to make sure you're able to go through and identify what's what and how to name it. So the first step, if you get your quiz or your test later this week, first step to do is go through and identify what type of compound everything is. So NaCl is our first compound up here. What I'm going to notice is that Na is a metal, so automatically I'm going to know this guy is ionic. So I'm going to put an I underneath him so I know it's an ionic. Cu, again, is a metal, so again, ionic. N is a non-metal, it's nitrogen, so I'm going to say that guy's covalent. H automatically tells us acid, if there's an H on in front. Al is metal, so ionic. H again tells us acid. Carbon is a non-metal, so covalent. Hydrogen tells us acid. Calcium is a metal, so ionic. Iron is a metal, so ionic. Carbon is a non-metal, so covalent, and hydrogen out in front tells us acid. Once we have all that taken care of, all we need to do is go through and be able to name these. So NaCl, ionic compound. Remember, our rules for ionic compounds tell us that we name the metal and name the anion with IDE if it's a general non-metal off the periodic table, and if it's a transition metal, we use Roman numerals. Sodium is not a transition metal, so we just name him sodium. Okay, chlorine is not a polyatomic ion, it's just an element, so it becomes chloride. So NaCl, sodium chloride. Now, copper, and another ionic compound, copper is a transition metal, so we need his charge. Remember, we get his charge from uncrossing and unswapping. So we get Cu plus 2, Cl minus 1. Chlorine is supposed to have a minus 1, therefore copper is supposed to have a positive 2. So now we just name this copper 2. Chlorine is still chloride. Okay, let's stick with all our ionics for right now. Al2SO4 3. Again, ionic compound. Aluminum's not a transition metal, so we just name him. So aluminum. SO4 is a polyatomic ion, so we just name him as well, and that's sulfate. Let me rewrite this so it's a little more legible. There we go. Alright, next ionic compound is CaF2. Ca is calcium, not a transition metal, so we just name him calcium. Fluorine becomes fluoride. Okay, Fe2O3, iron is a transition metal, so we need his charge, so we bring up our charges. We get Fe plus 3, oxygen minus 2, and remember the way we know which one's positive, which one's negative, the metal should always be positive, the second element should be a non-metal, so it's always negative. Double check your charges. Oxygen is supposed to be a negative 2, so we just name him now iron 3 oxide. Okay, so that's all our ionic compounds. Done. Let's go back and grab our acids, because they're the next most difficult, I guess we could say. H3PO4, we know it's an acid again because it starts with hydrogen. Now, this is a oxyacid, and you can always go through and next to your acids say whether it's oxy or binary. So H3PO4 is oxy because it has the oxygen. H2, and that should say SO3. Let me fix that real quick. There we go. And we'll just pretend that's a lower 3. Regardless, is also an oxy. HBr is a binary because it does not have an oxygen, and HClO4 is an oxy as well because it has the oxygen. Now, PO4 on our polyatomic ion list is phosphate. Remember, 8 goes to ic, ite goes to us. So phosphate becomes phosphic, and then we have acid. That's our second name. Remember, acid tells us there's a hydrogen out in front. Okay, SO3, and again, just imagine that's a lower 3 right now. SO3 is sulfite. Ite goes to us, so that becomes sulfus, or sulfurous, and again, acid. HBr, binary. So remember, binary, we always have our prefix hydro. We name the element, which is bromine, to bromide, and bromide turns into bromic, and then we add acid as our second name, so hydrobromic acid. And then our last one, ClO4, again oxyacid. ClO4 is perchlorate, becomes 8, goes to ic. There should be a C there. There we go. Chlorate goes to, or sorry, perchlorate turns into perchloric, and we add the ending acid. Okay, last but not least is our covalents. Remember here we just use our prefixes. 1 nitrogen, 2 oxygens. Remember we don't ever use mono 1 for the first element, so we just name this nitrogen. And remember to not ever change the ending of the first one, we leave it alone. Oxygen becomes di for 2, and then oxide. Whoops, sorry. Starting to write oxygen there. Oxide. Okay, C2H6, we do use a prefix because there's more than one, so we say dicarbon, again, not changing the ending of the first one. 6 is hexa, and hydrogen becomes hydride. Okay, and CO, carbon, we don't use the prefix because there's only one. We do use mono for the last element because we need to, and then oxygen becomes oxide, so carbon monoxide. Okay, so that's taking the compound to the name. Let's look at taking the name to the compound. Again, my first step would be to go through and identify whether it's ionic or covalent. Ionic, covalent, or acidic. Lithium is a metal, so this guy's ionic. Okay, aluminum also a metal, so this guy's ionic. Notice here we have acid in the name. That tells us acid. Sodium a metal, ionic. Whoops, it's not letting me write the under I. There we go. Lithium's a metal, so ionic. Dinitrogen pentaoxide. Notice these prefixes here. Also notice the fact that it's nitrogen and oxygen. 2 nonmetals with the prefixes tells us covalent. Carbon tetrahydride. Again, I see that prefix, I automatically know it's covalent because of those prefixes, but carbon's nonmetal. Hydrogen is also considered a nonmetal. Ammonium is my only polyatomic ion that acts like a cation. No, it is not a metal, but this is still ionic due to the fact that ammonium is a polyatomic ion, cation specifically. Sulfurous acid, notice the acid at the end of it tells us it's an acid. Calcium tells us ionic. Copper tells us ionic. Acid tells us acid. So now we just have to go through and name these accordingly. With these, if you're naming all your ionic compounds first or anytime, I would still go through and write out your charges just so you don't make any mistakes. Lithium is Li plus 1. Oxygen is O negative 2. Cross and swap, we get Li2O. Aluminum, Al plus 3. Sulfide is sulfur, which is S minus 2. Cross and swap, Al2, S3. Okay, we'll skip hydroiodic acid. We'll come back to him in a minute. Sodium is Na plus 1. Notice the ATE here versus the IDE. This tells us polyatomic ion. Well, phosphate is PO4 negative 3. So cross and swap, I get Na3, and I would still keep our monsters in a box as long as we need to, PO4. So Na3, PO4. Lead 4 oxide, we have Pb plus 4. Oxide O negative 2. Remember that these represent the charge of the transition metal. Cross and swap, and we originally get Pb2O4. Remember, these two numbers simplify into just PbO2. Okay. Ammonium is a polyatomic ion. It's NH4 with a plus 1 charge. Chloride is Cl minus. Cross and swap, our compound is NH4 parentheses Cl. Okay, calcium, Ca plus 2. Chloride is chlorine, negative 1. Cross and swap, Ca, Cl2. And last but not least, copper, 1 sulfate. That means we have Cu plus 1. Sulfate, Ate again, tells us SO4, negative 2. Cross and swap, Cu2, SO4. Okay, so that's all our ionics. Let's go back and grab our acids. Notice the prefix here, hydro. Hydro tells us binary, which means we are not dealing with a polyatomic ion, we're dealing with an element from the periodic table. So this next piece of it tells us what element we're dealing with. Iodic tells us iodine, which has a negative 1 charge. Acid, remember, tells us that there's a hydrogen out in front, because by definition, all acids start with hydrogen, at least the definition we're using. Cross and swap, Hi. Jump over here to our next one, sulfurous. Notice no hydro here, and notice the US at the end, OUS. That tells us this came from sulfite, which is SO3 minus 2. Acid tells us hydrogen out in front, cross and swap, H2, SO3. Again, nitric acid. Notice the lack of hydro tells us a oxyacid, so we look at our polyatomic ion list. Nitric came from nitrate, which is NO3, -1. We have acid tells us hydrogen, which is a +1. So nitric acid is HNO3. Okay, and last but not least, our covalent compounds. Easy peasy. Dinitrogen tells us N2. Pentaoxide tells us O5. And we do not cross and swap these. These are exactly the way they are. N2O5, leave it alone. Carbon tetrahydride. Carbon tells us there's only one carbon, because notice the lack of prefix. We don't ever use mono for the first element, so the fact that there's no prefix tells us 1. Tetra tells us 4. Hydride tells us hydrogen, so 4 hydrogens, CH4. All right, guys, that's about it for just identifying all of them, how to name them. Remember, test is Wednesday, and good luck.